Okay, now let me go back to my PowerPoint. In Charleston, you don't experience those type of congestion situations, but in the larger cities, that's common. So I wanted to share with you a movie to set the tone. ITS technologies were that they chose to use to help manage congestion were set up that they would monitor traffic conditions, metering traffic onto freeways, optimizing the timing of traffic signals, and implementing electronic money transactions on toll roads, and faster and anticipatory responses to traffic incidents, and then providing travelers with information on travel conditions as well as alternative routes and modes. These will go pretty fast. The first one was a call box, which is placed along the rural roads in the areas where there's cellular telephone use is not available, or there are really, believe it or not, people who don't have cell phones yet. So those are placed throughout along the roadside so that if you have emergencies, you can stop and call for assistance. Next one. Closed-circuit television is located above the roadways to watch for traffic accidents or different situations that need to be addressed. Those cameras can tilt, pan, they have full control over them, and each one of them has it's a lightning rod on the pole with them, so if the lightning strikes it protects those. The next one is a ramp meter, and it's designed to maximize the flow of the traffic on the ramps to get onto the freeways or off. And there are stoplights, and so there'd be 2 lanes, and the lights would control the traffic, but it keeps things moving along. Those are used where the volume of traffic are higher. Then the next one is the passive acoustic device or pad, and those are small devices that sit on the top of the utility bowls, and they detect movement and speed and density, and then that information is sent to their to the offices where they can then set up different scenarios to control those traffic, like to control the traffic lights, or they can send out emergency vehicles, whatever they need to do. The next one is called, they're loops, and those are embedded in the roadways. And I don't know if you can see them from behind, but the cars pass over them, and that reads and collects data on the speed and the number of cars that are going through. And then in some offices they have colored maps that the operator reads and then makes the necessary adjustment to take care of the traffic. All of those prior to are all sent, the information is all sent to a control cabinet. Those are along the roads, and then those are sent on in, the information then or data is sent on into offices so that the controllers can take care of that. Those are weatherproof and built to withstand whatever elements they're outside in. Once that information is sent in, then they can do, go ahead to the next one. Then they can do, they can send emergency vehicles out, or they can send messages to the dynamic message signs where it would say ramp accident on ramp or exit 196, take the next exit, or slow moving traffic, or I think I've seen one that says approximate arrival time, or it calculates the speed of the traffic, so it alerts you as to what is going on ahead of you, and you can make adjustments to your travel pattern. Next. The Department of Transportation then wanted to determine what the outcomes or how the emerging outcomes were happening through this new technology-based system. And in the fall of 1996 and to the fall of 1997, they collected this data based on the fact that reducing the number of crashes would directly impact everything else that happens in movement of traffic. And this is so that the percentage of reduction, it increased considerably in the measure. This is in the amount of time that it took you to get from point A to point B. And so it significantly increased throughout the time. The next one. Then the other was the operating costs and productivity. And the first one is the electronic toll collection, and where I'm old enough that I knew when I came to a toll booth I had to count out the change and hand it to a person, and then it evolved to you drove by and threw the money into the slot. Now then you can go right through, and it will. My sister has a toll pass, and she lives in Texas, and she drives through. They don't slow up a bit; they just keep moving, and the cameras read, or the computer reads that and then charges that to her account number. In northern Illinois, there it breaks off into 4 or 5 lanes, so that if you want to be billed or you have the pass, you can take the left lanes and accelerate. You don't have to slow up. If you want to pay, you slow down and sit in lines and risk accidents as you go on. The next one, which is not much of an increase, but it's the automatic vehicle locator and then the computer-aided dispatching, and that's more involved with the emergency vehicle situations. And then the fleet management, they saw some increase in reduction. The overall impact of the intelligent transportation systems have greatly impacted the consumers and the infrastructures of the cities. It costs, and I'll back up to my notes because I missed a couple of things here. In 2005, there was a loss of 2 billion hours, $100 billion in traffic delays, and $70 billion in traffic accidents, and approximately 2 billion gallons of fuel wasted annually. To build additional roadways to help alleviate the traffic congestion and to reduce waste in fuel and the release of toxic fumes and things into our air, it would run about $1 billion per lane mile to build additional highways. Through the intelligent transportation systems, it would cost only $50,000 per lane mile, and by doing the informational or the intelligent transportation system, it increases the capacity of the roads up to 20%. So it actually puts off having to do the major expenditures to control traffic. And